Hey people, it's good to see you. So I'm going to talk about large multimodal models and embodied AI. So yeah, we heard both speakers were talking about large language models. It was a huge AI breakthrough, so 10 years ago, we couldn't have imagined such level of reasoning and understanding for language. It's pretty good for language. And also, there's a larger topic of generative AI, so it's not just language, it's also images. It's also sound, as the previous speaker talked about. So, and these large language models are pretty good at these tasks. But as we know, they're not perfect. There are hallucinations, there are safety issues. Both speakers talked about that. And I really like this sleeper agents paper. So it's published by the Anthropic about the backdoor injection into the large language models. So the idea is, so you pre-train a large language model and you inject a backdoor. And then in production, given a trigger phase, the large language model will start misbehaving. So most of the time, it will behave normally, it will be helpful, it will give you all the answers that you want. But if you give the trigger phase, it will start misbehaving. And unlike real-world agents like James Bond and others, the secret weapon of this large language model was actually a scratchpad. If you allow a large language model to have a scratchpad to explain the reasoning, it is more powerful for misbehaving. And what I think it's also pretty cool that if you have a backdoor model, what they showed, if you employ reinforcement learning with human feedback, it gets even worse. So recently, a few weeks ago, Anthropic published another paper where they proposed some of the countermeasures how to attack this problem. But it's still work in progress. And what I personally think that OpenAI should have done that also for their models. For instance, not to wait some third-party university to conclude that the models are only 60% accurate, as we heard so far. So, okay, large language models are cool. They are everywhere. They're in finance. They are also summarizing law documents and stuff like that, all cool stuff. So what's next? What I think is next is like, we don't want an AI just to see. We don't want an AI just to talk. I think we want an AI that can do, so that can interact with the real world and operate in the same 3D world that we live in. It's what we call the so-called spatial intelligence. And these are actually, all the images are generated by DALL-E. So for instance, what I'm thinking about when I'm talking about embodied AI, so our self-driving cars, applications in health, robotic arms, surgeons operate. It's not a fan of autonomous forklifts, and also our smart homes. So where is embedded AI today? So when you look about it, the situation is not so similar as with large language models, where you have open models like Llama, you have this nice platform of Hugging Face that we are all using. It's closed. It's mostly in the hands of corporations, which is okay, but I mean, Waymo has their own data sets, large amounts of data, but this data is closed. It's proprietary. So also, you don't have global scale. For instance, Wave is collecting data only in London, and Motional is collecting in Las Vegas, in Singapore, and in Boston. So basically, how are you going to deploy such models in Berlin, in Zagreb, in Paris? So you need to have global scale. And when you think about it, all these shortcomings and this AI should actually coexist in public spaces with us. I'm sure that you all heard of these famous incidents of Tesla. where they shut down the full self-driving only a few seconds before the collision, the accidents happened. And what's happening here that the authorities have issued a large number of investigations into both Tesla, Cruise, Zoox, Ford, everyone. So it's not going to be a gray zone anymore. They're analyzing these footages of incidents, of collisions, of accidents, and also footage that people take with their own smartphones. So I think that the way that the problem was solved so far, it's not the way to go. It will not bring that much of the improvements that we've seen with large language models. It's closed. There's no big community working on the problem. And what I think, how should we approach the problem? We should take humans at the center, so not money, not revenue, humans. And we should really address safety. So, I mean, this embodied AI is going to coexist with us in public spaces, so safety should be our #1 priority. And if there's an accident, if a model fails, then we should also have this transparency so that we, as a community, oh, it fails here, or this is an interesting and hard problem, then everyone gets at it to solve it. So I think that transparency here is the key. So this is all like really nice, but how do we get there? So we at YAC, we have like a joke, internal joke. When the model misbehaves, we say, oh, it's either the data or the model, and oftentimes it's the data. So I'm going to start talking about the data and something what we call an open scenario map. So open scenario map, we're also big fans of OpenStreetMap, so hence the name Open Scenario Map. It's a collection, large collection of open world scenarios, so real world situations to test embodied AI. So basically, what you need to test embodied AI in the 3D world, in a physical world? You need some kind of map, and you need to also be aware of dynamic objects around you, and also of the traffic infrastructure. So basically, what I'm talking here is the task of autonomous driving. But in general, like 10 years ago, I personally, when I was a PhD student, I trained separate models for detecting traffic signs and separate models to detect pedestrian crosses. We had models separately to detect cats and dogs and blah, blah, blah. But basically, nowadays, it's common knowledge. We have models which can detect both cats, dogs, traffic signs, whatever. And I think that this is also the way that we should approach this problem of interaction and action with the real world. So basically, if you have a car, if you have a forklift, if you have a delivery robot making a curbside delivery at the supermarket, there are similar, to say so, features which all these agents could use and could benefit from the overall knowledge. So it's also scalable to other tasks. And when I think humans at the center, it's also inspired by the way as we as humans learn. And how do we learn? We go to driving schools, we take a certain number of lessons, then we take a test, then we fail, as I did in my case, then we take additional lessons, take another test, and until we get the driving license. And I think that this is also a lesson that we should learn from here. And okay, so how do we as humans learn? We learn by interacting with the world. I think that the key idea of embodied AI is this interaction. It's not just seeing, it's not just observing, it is interaction. So we learn by example. When we learn to walk, our parents show us how. When we learn how to eat, they also show us. So these examples. And we also learn by mistake. So we try walking, we fall, we get up, and we try again. So how to translate these ideas into embodied AI? So basically, this open scenario map is being collected by driving schools. So we have partnerships with 60 driving schools in Germany, Denmark, and every day they are collecting over 30 terabytes of data. So we have students and we also have expert drivers. And these expert drivers are also driving the same routes as the student do. So in this way, this data is aligned with the human core values by default. So you don't need like additional reinforcement with human feedback step, because the data that we are training the model is by default safe. And I think that that's really important, because many of the steps, many of the problems that Christian also mentioned are due to the fact that the models are trained in two phases. So in the first phase, you train on internet on large amounts of data, and then only afterwards you go and you align this data with human values. And it's also similar with kids. Like if one parent tells the child it's okay to fight back and hit another child when there's a problem, and the other parent says, oh no, you should talk first, you should try resolve the problem with words, there's going to be problems. The child is going to start misbehaving. And I think it's also similar with the models. And the other thing is we also learn by mistakes. So we have student drives which are curated by experts. So we know that when instructor press brakes, so to avoid collision. Also, we know when the person forgot to do the visual check, or when the placement inside the lane was not so great. So we also have annotated and curated this student data, which allows us to also to use these counterfactuals and sometimes to detect out of distribution data. Because there are mistakes which are common, situations like which are hard to us as humans. For instance, this is one of my favorite intersections. It's in Passau. So first time when I was creating these slides, there were 37 errors here. And before I sent slides to Alexa, there were already 49. So it's an unsignalized intersection. There are no traffic signs, there are no traffic lights. And you have multiple digitized geometry, so you have multiple tracks for each direction. And people often make mistakes, whether they turn left or they turn right, whether there is sunny and you have like this dense traffic, or if it's night, and for instance in this image it's snow. And what I think really is great about this data, that when you go to driving schools, when we are borrowing the way that humans are doing things, you need to do a certain amount of night drives. And also, many students like take their driving lessons until once school finishes or they're finished at college. And in the winter, at 5 o'clock, it's already night. So basically, you get all these different conditions and ODDs in the data. So this was the data, but we're all here about large multimodal models. So basically, nowadays, all these large language are multimodal, and they can understand images. Hopefully soon, they will understand also videos. And they can understand and they can generate sound. So what I'm talking about is the AI that can generate action, that can interact with the world. And so when we take a step back, what actually enabled the large language models to be so good? There are three things. One is self-supervised learning, so that you don't need to have large annotation teams which annotate your data, and then if you want to scale, you want to detect another class of objects, then you need to give them a sufficiently big data set to annotate this data, and then you train and blah, blah, blah. So basically, as Jan LeCun said, self-supervised learning is the dark matter of intelligence. The second one is the transformer architecture, which has exhaustively been used in 2017 when it was first introduced. And finally, we will talk about fine-tuning and aligning with human values. So what the real power is, you have this general model. It runs what language is, and then you can fine-tune it for all sorts of applications. So the question is, can we do this for action, for interaction? So for LLMs are language models. So basically, they predict the next word. So you have this sentence like, attention is all you, blah, blah, blah. And the probability is that it's a high probability that will say that the next word is need. But how to apply that for large multimodal models, for instance? So say we have a robot navigating through the warehouse, loading and unloading pallets, or we have a car in the public streets. And say you have this video of frames of images that a robot or a car is taking when driving through the environment. And on the other hand, you also have the CAN data, so when was the vehicle braking, when was it accelerating, when was it steering. And could you take just this data without annotations, without images where you have a ton of people annotating, oh, this is a pedestrian, this is a bicycle. I mean, I used to do that like 5 to 6 years ago to train models for autonomous driving in such fashion. But here, can you just give it a sequence of frames and actions and let the model learn what would be the most safest and the best actions that it can do? So for instance, here, if a cyclist, I don't know how much you can see, appears suddenly in front of the car, that the car would infer that it needs to brake and it needs to go around it, and also to imagine how will the future look like. So for instance, there are multiple possible futures. For instance, and that's why generative modeling is so great for this task. For instance, on each intersection, the car can go left or can go right, and it's really nice to model these probabilities. So both futures are equally possible and possibly equally important. So you have all these different modalities. You have images, which are high dimensional, a lot of information, a lot of perceptual information. And then you have actions, which are 1D signals. And then you have turn signals, which are maybe the closest thing to text. So you go left, you go right, you can go straight. How to get all these modalities to talk to each other. So if the car stops, we need to make sure that it really stopped because there was a red light at the traffic light, or if there was, if a pedestrian decided to go over the road. So we need to like really connect these different modalities. And how do we do it? We tokenized both images and actions, and we use them as an input to the transformer. As Karpati said, tokenization is maybe not the most exciting part of the whole AI hype, but it's often maybe very, very important, if not the most important one, because many hidden errors can arise if tokenization went wrong. And then, once you have these tokens, what we use a spatio-temporal transformer to learn a world representation. So basically, it's not enough to have a single image. It's similar to the language. It's an autoregressive model. So you predict the next action, and based on this action, you predict the next action, and so on. And the architecture, so we are training causal transformers on clips of, so several time steps of images and of actions. So, and by training this causal transformer, we are doing the same thing that the language models are doing with pre-training. We are learning a shared representation. So this model is, dumb would be the wrong word. So only thing that he knows is to predict the next word and to predict the next image of what will the surroundings look like. But maybe you also want to fine-tune it to do other things. You want to fine-tune it to score driving. So for instance, if you could pass it a video of how you drive, it could tell you how you drive, it would give you some score, it could give you what you did wrong, so detect your mistakes, detect incidents. And so it could also be used to extract scenarios. One thing is that people often say, and also our keynote speakers tells us that we're never going to have L5 because there are always going to be situations where both choices are wrong, and we as people will do the wrong choice. So basically, what we want to know when we are validating, is the embodied AI safe to let it in the real world? We want to actually detect this unusual, this long distribution, these unusual situations which are difficult. And I think that also using this pre-trained model and fine-tuning it to detect incidents, to detect these really hard situations, is the way to go to earn the trust and to rigorously test the model. And with that, I would conclude my talk and invite the audience for questions. No questions, okay. Either I was utterly boring or everything was, oh, one question.
Data sharing. How do you see this, let's call it upcoming?
Can you please repeat the question? Yeah.
Yeah. So a little question on the data, the amount of data, types of data, data from communities for these models. How do you see this upcoming, let's call it Data Governance Act regulation that wants to trigger this data altruism, let's say these data intermediaries that will support these data sets that could help these type of models? How do you see these initiatives helping what you are doing? Let's say, do you see some need that public and something outside of corporations also need to be involved in this type of work? Because this is, let's say, a thing with driving schools, so they needed to also be part of this to actually make some positive impact, I would say, on this embodied AI you're working, right? So just a little bit of your expert perception on these things that are happening around regulation and data altruism, and maybe more data is needed, better involvement of public also on this.
Yeah, I think it's a right question. We as a company, we are working with German governmental agencies and also with universities in Germany. I think that the $1 million question that people are trying to solve here for embodied AI is how to like detect that it is really safe. Because there are no handbooks, there are no regulation, there's currently no regulated book of rules for automated vehicles. And this driving school data is collected by many driving schools, so it's unbiased data. So it's not like Wave collected or Waymo collected or anyone else. And we plan to open it for everyone to use. So if Wave wants to test how to drive in Berlin, not just in London, they could use the open scenario map to test it. So the amount of data that we have, it's like very good coverage in Germany. Almost all Germany is covered, part of Denmark, and it's easily scalable to different countries. For instance, there are driving schools in Zagreb, so they can partner with our partners, they can install the cameras and everything. We use very cheap sensors, so only cameras, no LiDARs. So basically the whole setup is pretty cheap, very easy to install, and very easy to collect the data. And the data is, if you use expert data, and experts really know how to drive, those are people that drive for over 30 years and they know how to obey law. So basically, if you use this kind of data, then the data is safe by design, and the models should also be safe by design. So I think that collaboration with governmental authorities is here also important.
Yeah, thanks. That's it. I would say if it's wider for more countries, let's say governmental agency plus other institutions that are involved in traffic safety must be part of the journey, right?
Currently, it's in Germany, but it's scalable anywhere else. Yeah.
Okay, thanks. Thanks.
Thank you.
Okay, thank you very much, Valentina.